My name is Johnson Zhong. I am a Year 12 student from Yucheng International School of Hong Kong and a participant of the Eureka one-on-one research workshop with my instructor, Dr. Cameron Taylor. As I did not have much prior experience with artificial intelligence or machine learning, I decided to choose a research topic in computer vision, the field Dr. Taylor specializes in, and I chose to write my research on semantic segmentation. While I continued to learn a lot more about semantic segmentation and object detection in general, I was curious about how deep learning algorithms would perform in trying to identify objects in actual images versus when it was drawn by an artist. My 2-month research journey included 5 main parts. So, I began with online research, which meant reading a lot of research papers and online resources, a large amount of note taking and searching up definitions of unfamiliar terms in the field, which was quite time consuming and tedious when I began, but eventually became easier as I became more familiar with the terminology and general structure of research papers thanks to Dr. Taylor's explanations and a lot of hours of reading. So, with my previous experience with coding in Python, I was able to create an experiment where I compared the performances of the faster RCNN and retina object detection models on real images, realistic illustrations, cartoon images, and abstract illustrations. My hypothesis was that the object detection models would become less accurate in their predictions as the images of the same objects would become more abstract. I also thought that since abstract illustrations were less detailed, they should also include some of the more important or salient features of the objects the artworks were depicting, which also meant that it could be valuable for deep learning models to use artworks which emphasize the more salient features of an object as training data to improve a model's performance in identifying objects in real life. After performing the experiment, I spent a few days manually counting the number of pixels, which were true positive, or false negative in each of the 80 predictions in the experiment, and recorded the results of the experiments in a table, which I also used to calculate the intersection over union of each prediction and averaged to compare the two models' performances. This was also quite time consuming and monotonous, but I was still able to get a fairly accurate result that could reveal a strong pattern in the data I collected. I have also linked the table of my results on my final paper in the appendix. So, with all of the numbers, I created graphs using matplotlib in Python, which clearly showed the decreasing accuracy of both models as the images or illustrations provided became more and more abstract, thus proving my hypothesis to be correct. There was another unexpected finding of a large disparity between the accuracies of the two models in identifying images with a single object and images with multiple objects. And it was found that while the faster RCNN model had a similar accuracy of about 45% mean intersection over union when identifying single object images and multi-object images, the RetinaNet model had a much higher accuracy of 64.86% in identifying multi-object images compared to the much lower accuracy of 39.21% in identifying single object images. In my paper, I wrote that this large discrepancy may also be because of the greater sampling rate of the RetinaNet model, or I also think it could have been due to some kind of inaccuracy in my manual method of counting the number of pixels. Finally, after all of my research, I began to document my findings. I found the writing segment the most challenging, as I was unsure at times about what aspects or features of the topic I should emphasize more in my writing, particularly for the related work section. In this project, my main takeaways include a greater insight into the research process, as I have more of an idea of how research is to be conducted, even though I am aware that what I have written is of little value to the scientific community. Through this experience, I have also learned a lot more about specific applications of artificial intelligence because I did not have much prior experience in deep learning or computer vision specifically. Although I did enjoy learning in the field of computer vision and semantic segmentation specifically, I plan to explore some other fields of artificial intelligence before I narrow down my interests with the research skills I have learned in this experience. Lastly, I would just like to say that I'm very thankful for Dr. Taylor's help during the entire research process, as I would not have been able to complete my online research or experiment as successfully without his support. This is all about my research journey. Thank you.